two concepts, the geometric series and the trigonometric functions. So when you see two topics combined together, don't panic. It means that it's an easy problem because their aim is for you to panic. So this is why they combine things together like that. But when you start working, you will notice that it's very easy. So let us start reading it. The first three terms of the geometric series are sine theta, cosine theta, and 0.5. So you just start naming them, u1, u2, u3, so that you would know their places. Now show that this quadratic, you're going to reach this quadratic equation. So the first thing that you have to think of is how to combine these terms in order for you to get this. And since you have a geometric sequence, therefore you have to use the formulas of the geometric sequence. Now I've posted here the formulas paper that you're going to get. And the formula paper gives you these geometric formulas, okay, only. Now this one is the general term of the nth sequence of a geometric series, and I'm going to give you this one, which I already gave you in the videos. Un is equal to up r n minus p. Now, why is this more applicable or more feasible than this one? Because up is any term. Any term means any term they give to you in the geometric sequence. You just replace it here and you know its place. You can use it and find the answer, or find r, or find un. It depends on the question. Now, why is this restricting? Because they tell you un is equal to a, which is the first term, rn minus 1. First term is a. So if they don't give you the first term, or you don't have it, this would be a little bit difficult to use. Whereas this one is more flexible, because any term they give it to you, you just use it here. Now the thing is, the drawback is that they don't give you this formula. So this is how you're going to memorize it. So they gave you in the booklet un a r minus 1. So instead of the first term, you write up, which is any term. And instead of the one which is represented by the first term, you just write p, which is the place of the any term that you chose. And you can work using it. Now, in order for us to use, to combine the terms that they gave us and to form a quadratic equation, we have to have in mind that the ratio is a very important part in geometric sequence. Why is that? Because you have a constant ratio all over. What do we mean by constant ratio? R is equal to U3 over U2. R is equal to U2 over U1. R is equal to U7 over U6. 6, which means that R is the ratio of the two consecutive terms, such that you take the cosine theta over the sine theta. And then it's the same R in a geometric sequence, where you take U3 over U2, which is 0.5 over cosine. So why is R very important, and why you should use it in the geometric sequence in these cases? Because it's constant. In order to have a geometric series, you have to have a constant ratio. And this constant ratio is made up of the fraction or the ratio of two consecutive terms. You cannot write U3 over U1. U3, under it you should have U2. U5, under it you should have U4 in order to have the constant R. Questions?
It's perfect, miss.
Okay, I hope so. So now you start. After you write the ratios, you know that the ratio is constant. Therefore, you put the two fractions equal and you cross multiply, and from there it's algebra. So it's cosine squared equals to 0.5 sine theta. And since they need, in the given, they need all the terms or all the function to be sine, therefore you have to change cosine squared theta. You reach this phase, and in the end, you will see that, Abel. So you reach this one. Now this one has a decimal number in it. So you change it into a fraction. And while you change it, when you change it into a fraction, you notice that you have a denominator. And in the given equation, you don't have a denominator. So you need to get rid of the 2. To get rid of the 2, you multiply everything by 2. And when you multiply everything by 2, you get what they want, which is the quadratic equation of this form. Now, why did they give you actually the quadratic equation? Because you're going to use it later. So if you didn't reach in part A what they want, then you can use in the coming parts B, C, and D, you can use directly what they gave you, and you will not lose the rest of the marks. We continue giving that theta lies in the interval between 90 and 180. Find the value of theta giving your answer to 1 decimal place. So this is what we're going to use in order for us to solve for theta, which is already given to us. I prefer that we change the variable. So let m be the sine theta, and when you change the variable, this is the equation you're going to get. Now this equation is much more comfortable to work with. Those that would like to work with this one, no problem. Okay, and those that get overwhelmed by seeing the sign as a quadratic equation, so change it into, change the variable. And then you take delta, and after you take delta, you are going to find the values of m, and these are the values of m. Now, if you're with me and you're thinking, you're going to tell me, since they asked for decimals, why do you do delta? No problem. You don't want to do delta, you can implement directly this equation and you solve it on your calculator and you get the decimal numbers. Why do you need to reject? Because sine of an angle cannot exceed -1. So we're back to the trigonometric circle. The maximum that sine can take is 1 in the positive side and -1 in the negative side. So -1.2 is rejected. So the only number you can accept is this one. Now, when you accept this one, you need to change it into degrees. How are you going to change it into degrees? You're going to say sine inverse of 0.78077. I prefer that you write it all, because use the answer key on your calculator. It's better and it will give you the accurate answer. So as you can see here, sine theta equals to sine the angle that you found after you did the sine inverse here. So sine inverse of the number is equal to 51.3 degrees. So theta is equal to 51. This is the first case. And this is an acute angle which belongs to the interval they gave us. So this is the interval they gave us. And or theta is 180 minus 51.4. So you have to specify that this is an acute angle and this is an obtuse angle. Why is that? Because you need to check, does it belong to the interval they gave us, okay? So 180 minus the angle is equal to the angle in degrees, 128.7 degrees. So the main important thing is, one, let me summarize. One, you have to sign inverse 0.78 blah 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 that you accepted, because you rejected this one. Then you will say that theta equals to 51.3 degrees plus 360 degrees K. When K is 0, you've got this angle. You check, is this angle in here? No. So you move on. Also, since this is sine, you have theta equals to 180 degrees minus alpha. You have to take both cases, plus 360 degrees K. So when K is 0, 0 turns, it means this is equal to 1 to 8.7 degrees. Is this in this interval? Yes, it is. So this would be the answer. Now, why don't we try K equals 1? If we try K equals 1, then you are adding to 51.3 a turn, a full turn, which is out of this bound. Also, the same thing for this angle, when you are adding 360, it's not in this bound anymore.